All right, in this video, we're going to talk about a few situations that we have not yet seen with systems of equations. So in this first problem here, we have two equations that you may notice have the same, what? Slope. Well, what happens with two equations that have the same slope? What does that look like? Do you remember? Well, let's graph it and find out. So the first one here, I'm going to graph in blue, and then we'll graph the other one there in green. So first, we look at the y-intercept, which is 4, so we go up 4. 1, 2, 3, 4. This is the y-axis here. This is the x-axis, just to be clear. Put our y-intercept right there, and then our slope is 3, so that means that our rise is 3, our run is 1. So 1, 2, 3 over 1. Positive 3, right? It's the same thing as going down 3 and left 1. When I say over 1, I meant right 1. That's important to say. So that means rise up 3, right 1, because they're both positive. Rise over run. That's the slope. Okay. Now, let's just graph this thing here. Draw the line. And then I said we'd graph this one in green. So right here we have the y-intercept of -1 right here. And then again, the slope is going to be 3. So 3 is the rise, and positive 3. And run is 1, positive 1. So we're going up 3 and right 1 again. Okay. So up 3 and right 1. Up 3 and right 1. Down 3 and left 1. Down 3 and left 1. Well, these are all points on the line, so we're just going to graph it. Now, what are you noticing here when we graph both of these lines? Interesting. Doesn't look like they intersect. Not in this graph anyway. But the fact is they actually don't intersect. They don't intersect at any point anywhere because they have the same exact slope. Remember? Lines that have the same slope are parallel. Remember that word? Parallel. And they never intersect. Here's a little symbol for parallel, right? So if they never intersect, then does this system of equations even have a solution? No, it doesn't. So this would be an example of a system of equations with no solution. Okay? There is no value of x and y that makes both of these equations true. Doesn't exist. Okay, how about number 2? So we have two equations that we're going to have to first put into slope-intercept form before we graph it. So let's do that, okay? Something else we're going to have to get used to in this video is putting them in slope-intercept form first. So I'm going to do this one in red. I'm going to write it over down here again, okay? 2y equals 5. So what we're going to do is we're going to get this y, or excuse me, get this y to be by itself on the left side of the equation. And then we have to divide out the 2y. And remember, dividing the entire right side by 2 is the same as dividing each of the terms on the right side by 2. 2's cancel. Y equals -1/2 x plus 5 over 2, 5 halves. All right, so 5 halves is the same as 2 1/2, just FYI. Now we're going to look at this, so that was this one right here. Okay, now we're going to look at this one and do it in blue right here. And we're going to do that one right there. 2x plus 4y equals 10. And we're going to put this in slope-intercept form. Okay, so same process. We're going to move the x terms over. Keep the y on the left side. So -2x plus, sloppy here, 2x plus 10. And then we're going to divide all sides, or each side, by 4. Each term by 4 on that right side. Okay, so 4's cancel. Y equals negative 1/2 x plus what? Well, this simplifies to 5/2 because we can divide both the top and the bottom by 2. So plus 5/2. And guess what? We have the same equation. So when we have the same equation, I mean, it wasn't in the same form at first, right? They looked a little different at first. But when we put it in slope-intercept form, we noticed that these guys are exactly the same. This and this. Doesn't matter. You're going to get the same thing, right? So what is the solution to this system of equations? Well, first let's just graph the line here. I will, because I put a coordinate plane. So we're going to graph the red one first. I'm going to graph the red one first. So 5/2 is 2.5, so it's about right here. And then we're going to go rise, which is -1/2, which is the run. So that means down 1, right 2. So down 1 would be to the 1.5, and then right 2 would be right here. Okay? And then, so down 1/2. That's kind of right there in the middle, but that's okay. And then we've got, well, extend that line a little bit. Got this. And then we've got our blue one, which is exactly the same, right? So our blue one's going to lie right next to the red, or right over the red. It's going to be right where the red is. So this is an example where you have the same line. That means you have infinitely many solutions. Everything's a solution. Why is that? Because they share every single number. Okay, infinitely many solutions. Okay. Number 3. Now this one is just like the ones we've been doing. However, it's not exactly in slope-intercept form now, is it? So we're going to have to first put it in slope-intercept form. So again, I'll take this one down here. I'll just copy this. Copy, paste. I'll take this down here and take x off that side. You want to try this one on your own, guys? It's probably a good idea. Pause it and try it on your own. Pause it. Okay, and then cancel those 3's there. Y equals -1/3 x minus 1. That's this first one up here. And then the second one is going to be over here. Take this and take that 2x over. -3y equals -2x plus 12. Divide every term by -3. And then you've got y equals, that would be a positive 2/3, x, y, because you got a negative divided by a negative becomes a positive, and then plus 12 over -3, so that would be -4. Okay, so what we're going to do now is actually bring this down so that we can see our graph with our equations. So in pink, we are going to graph this one. Whoa, I didn't want to do that here. In pink, we're going to graph this one. -1/3 x minus 1. So -1 is our y-intercept there. And then what is the rise and the run? Well, I'm going to say the rise is -1. The run is +3. Remember, if it's negative, the slope is negative. That means that only one, the rise or the run, has to be negative, not both. Okay? So negative 1, so that means go down 1 and then right 3. Down 1, right 3, down 1, right 3. And that's our line. Okay, that's that line. And then in orange, we're going to graph this one. So negative 4, negative 1, 2, 3, 4. So positive 2/3 is our slope right here. That's going to be up 2, right 3. So 1, 2, right 3. It looks like it intersects right there at a very clear 3, negative 2. So up 2, right 3, up 2, right 3, left 3, down 2. There's our second graph right there in orange. And our intersection point right there, like I just said, was 3, 3, negative 2. So therefore, the solution to this, what am I going to write it in? What am I going to write the solution in? This system of equations is x equals 3, y equals negative 2. And we're done.